Okay, so in this video we're going to discuss graphing piecewise functions and their domain and range and evaluating a greatest integer function. So let's look at our first example. So we need to take it piece by piece, just as it says, a piecewise function. So let's look at this first piece. So remember that the first thing that we always do is plug in the given. Okay, so I'm going to plug in -2, and that's going to give me 2 times -2 is -4. Now remember that the inequality symbol will determine whether that first dot, that end point or starting point, is closed or open. And because it's equal to, I know that that's a nice closed dot. Now I need 2 points to graph a line, so I need to choose an x that is less than -2. So let's choose -4. 2 times -4 is -8. So I need to plot these points. So I have -2, -4, nice closed dot, and then -4, -8, nice closed dot. Okay, minor malfunction. And then connect those in that order. So remember that this is your starting point. Less than is left, so values to the left of that starting point. Now please remember that every single dot on your graph should be a closed dot, except for endpoints, like in our second equation, that do not have an equal to. Those are the only points on the entire function that have the option of being open. Every other point should be a closed dot. Okay, so for our second piece, we're going to plug in -2 first, and as I already said, because this doesn't have an equal to symbol, I know that's going to be a nice open dot. So I have -1 minus a -2. So a -1, a negative and negative makes a positive, and 2 plus -1 is +1. The second point happens to be an end point. So I know that's going to be an open dot. Again, no equal to, open dot. So I have -1 minus 4, which is -5. Okay, so I have -2, +1, open dot, +4, -5, open dot, and connect the two. Okay, our last equation is a nice constant function. Again, first point I'm going to plug in is my endpoint. So the only option I have to get out in a constant function is one value, -3. Notice this has an equal to, so I know that's going to be a nice little closed dot. So this says I need to pick an x greater than 4, so I'm going to pick +6. -3 times when I plug in 6, I only have the option of getting out -3. There's no x value. This is a constant y equals -3. So I have 4, -3, the nice closed dot, 6, -3, nice closed dot, and connect them. Okay, so then let's look here at our domain. So we're going to take our straight line, we're going to move across the domain until we get to that first spot of our graph in red, which is an arrow. That arrow tells me that, pointing to the left, tells me that the x is going to continue in the direction of left, which is -infinity. Okay, the next thing I'm going to do is I'm going to keep tracing the red, and I get to an open dot in the green. But notice in the green is open, but it lines up with that closed dot in red, so x equals -2 is defined. So I'm going to keep going. The same happens with that dot at x equals 4, have an open and a closed, and then I continue on to an arrow pointing infinitely to the right, which tells me +infinity. Okay, so I'm going to take my line and rotate it so that we can do range. So remember, in range we start from the bottom and go to the top. So from the bottom, as I come up, the first thing I touch is an arrow going down, so that's -infinity. Then I'm going to keep tracing, take my line up the red, so I have that open dot in green, but notice it lines up perfectly with a closed dot in red. So I'm going to continue. I have some overlap, which doesn't change my range, all the way till I get to the highest point at y equals 1, but that's not included, and when we show a not included point, we do that with a parenthesis in interval notation. Okay? So let's look at the second equation. We're going to do the same thing. I'm going to start with this first one. We always start with our endpoint. So I have xy. So when I plug in 0, I get out 0. Now this has a less than symbol, no equal to, so that's a nice open dot. Then it says I need to pick a value of x less than 0, so we can pick -2. -3 times -2 is a +6. So I have a nice open dot at 0, 0. And then I have -2, +6. Okay. Move on to our second linear equation. Again, this one has two endpoints, 0 and 6, so those are the two I'm going to use to graph. When I plug in 0, I get -1/2 times 0 minus 1, which gives me 0 minus 1, which is -1. It has an equal to symbol, so I know that's going to be a nice little closed dot. Then I'm going to choose 6, so I have -1/2 times 6 minus 1. -1/2 times 6 is -3, minus 1 is -4. And that's going to be an open dot. Notice again, has no equal to, open dot. So I have 0, -1, closed, and 6, -4 is going to be open. And I'm going to connect the two. We have our last equation. Again, the first point that I'm going to plug in is that 6, and it's not equal to, so it's going to be open. So I have 6 minus 7 is -1. And then I'm going to choose a value greater than 6. Let's do 8. So I have 8 minus 7, which is +1. So I have 6, -1 with an open dot, and then 8, +1, closed dot. Okay? So now we need to do domain and range. So let's start from the left to right. So the first thing I come to is a red arrow pointing to the left. So remember that we don't care whether the line is going up or down, because up and down talks about the direction of y, or range. So we're only concerned with left and right. The arrow is pointing to the left. Therefore, I know that it's going infinitely to the left, and we write that as -infinity. So I'm going to pick my line back up, keep tracing the red, and I have an open dot in red, which is nicely covered by the green closed dot. So I'm going to keep moving until I get to x equals 6. Now I have a problem, because at x equals 6, the function is not defined either in the blue or the green. I have two open dots, so I have to disclude 6. So I'm going to put 6 with a parenthesis. But notice the graph picks right back up on the other side of 6. So we have everything infinitely close on the left side of 6, everything infinitely close on the right side of 6, just not 6. So we're going to put our U to show we have a gap. Going to pick right back up at 6, and from 6 we trace the blue to an arrow pointing to the right, which means +infinity. Okay, so we're going to take our line and flip it so that we can do range. So from the range, we come from the bottom up. We don't touch an arrow first. We touch a nice little open dot at y equals -4. Okay, so that means that as low as our graph goes is infinitely close to y equals -4, and we show that open dot with a parenthesis. So we're going to keep tracing our graph. We're going to come up in the green. Now we have an open dot right here in blue, but that's covered with green. And we have this space between the green and the red, but notice how it covers here in the blue. If you'll watch the orange line, nicely covers. Open dot in red, covered in blue, and we continue up to a red arrow, which tells me +infinity. Okay? So the last thing we have is a greatest integer function. So remember that the greatest integer function talks about the greatest integer so far. So if you're visualizing this number on a number line, it's always the number to the left. The number to the left of where you would plot this point. So let's do f of negative 1.3 is equal to 2 times negative 1.3 minus 3. So I have negative 2.6 minus 3, which gives me negative 5.6. And the number to the left would be negative 6. Now, a good check before you turn your paper in, before you call yourself finished, look in your column, your y column, and if you have a decimal or a fraction, you have not completed greatest integer correctly. You should only have integers in the y column, so whole numbers and their opposites in the y column. So we have f 0.4. So I have 2 times 0.4 minus 3. 2 times 0.4 is 0.8 minus 3. Negative 2.2. And the greatest integer of negative 2.2 is negative 3. Okay? Then we have f of 2.7. So I have 2 times 2.7 minus 3. So I have 5.4 minus 3 is the greatest integer of 2.4, and the greatest integer of 2.4 is 2. Then I have f of 3. So I have 2 times 3 minus 3. 2 times 3 is 6, and 6 minus 3 is 3, and 3 is an integer, so the greatest integer is itself. The last one, 3.1. So I have the greatest integer of 2 times 3.1 minus 3. 6.2 minus 3 is 3.2, and the greatest integer of 3.2 is 3.